In this video, I'm going to demonstrate how to graph a cosine function in the Connect Math and ALEKS system. So this problem specifically corresponds to a cosine, but the steps you would take here to graph a sine would be virtually the same. So as with any situation where you're graphing online, just a few words of advice. Number one, make sure you read the directions very carefully. Make sure you know exactly what the system is looking for, and make sure your answer has all of those features. So in this situation, we have our function given. We want to identify the key attributes, specifically the amplitude, period, phase shift, and vertical shift of the function. And then we want to graph the function and identify the key points on one full period. So there's a couple of specific things to notice in step B. We're identifying key points, and we need to graph a full period. So one full period of the function, what we normally graph on paper. And by key points, what's meant there is we want to identify locations where the function hits its midline. We want to identify locations where the function hits its maximum and minimum values on one period. So essentially the 5 key points we normally graph on paper, those are going to be the points we want to identify and locate on our graph when we do it online. So we're going to start with those key attributes, and then we'll generate our graph on paper. We'll translate that into the homework system. So let's do everything on paper first, and then we'll translate that back into the other system. So here's the function. I have it written down. Let's start with all of our key attributes, all of these things that will be reflected when we graph this function. So the first key attribute of our function is its amplitude. Think of that as the wave height. So from the center of the graph, how far up and how far down do we go in terms of a number of units. So remember, our coefficient for our trig function is going to give us our amplitude, so specifically its absolute value. So the amplitude of our function will be the absolute value of 5, which is 5. So from the midline, we'll go up 5 units, we'll go down 5 units. Now the period is going to tell us how far we're going to have to go to start and finish our graph. In other words, to essentially get one picture or one little snippet of what the graph is going to look like. It's what we would copy and paste continually to generate the whole cosine graph. So the standard period for cosine is 2 pi, and we always divide that by whatever our coefficient for x is. So in this case, we're dividing that by 2. So 2 pi divided by 2 is going to be pi. So the period for this function is going to be pi. So essentially what that means is that we'll complete one period in half the distance from what the normal cosine's period would be completed in. Now a phase shift is going to be a shift to the left or a shift to the right, and we know we have a phase shift if there is a value added or subtracted from x inside of the trig function. Now we have to be careful here. Remember, there's a little bit of an issue with the sign. If we're subtracting here, the shift is in the positive direction. If we're adding, the shift is in the negative direction. So because we're subtracting, we know this is going to be a positive shift. So we're going to take our value pi over 2, and then this, as with the period, also has to be divided by the coefficient on x, which is 2. Now be careful here. These 2's don't cancel out. We have fractional division, which is the same thing as multiplying by the reciprocal of the denominator. So our actual phase shift is going to be pi over 4 units, and to be sure, that's going to be pi over 4 units to the right. Okay, now we have our vertical shift. Do we have one? In this case, yes, we do. We're adding on a value to the function as a whole outside of the function. So that's going to take all of the standard y values and it's going to shift them up by 2 units. So our vertical shift has a value of 2, and again, just to be clear, that's going to be a shift up 2 units. So before we continue on from there, let's go ahead and input these values into the system and make sure these values are correct, and then we can proceed with generating the graph. So let me flip screens real quick. Okay, so our amplitude, we determined that our amplitude is 5. So let's check that. Okay, that looks to be correct. Now we determined that the period is pi. Now notice we're not going to be able to type in pi, but we have the pi button here, so we can just use that button. Let's check it. Okay, that's also correct. Next thing we want is our phase shift. Now remember, the signs here matter. When we have subtraction inside of the function, it's actually a positive shift. It's a shift in the positive direction. So it's going to be positive pi over 4. So here's our fraction. We need our pi. We need our 4. Let's check it. Okay, pi over 4 is good. and then we have a vertical shift. The vertical shift is upward because we're adding, and it's upward by 2 units. And let's check that. Okay, so all of those attributes are correct, which means we can proceed with the understanding that these are all the attributes that this graph is going to have. So let's look again and let's see if there's any new information that we've been given. Okay, so we want to graph the function, identify key points on one full period. We want to plot all points corresponding to relative minima, relative maxima, and x-intercepts. So essentially where we hit the midline, okay, where we go up, where we go down from there. So keep in mind where we normally cross the x-axis on the standard cosine and sine graphs, those values may have shifted depending on what's happening with our function. We want to graph the new values based on where they've shifted. Okay, so let's flip back over. Let's see if we can get our graph on paper, and then we'll translate our points over here to the graphing system. Okay, so I like to start by determining what the starting and ending values of our period are going to be. Based on the fact that number one, we've changed the period, it's not as long as the original cosine period, and number two, we've shifted. We're no longer starting at 0, we're starting at pi over 4 units to the right. Both of those changes have an impact on where the graph is going to start and where the graph is going to end when we graph one period. So our standard period for cosine graphs from 0 to 2 pi. So we want to see how these values impacting x are going to impact those endpoints of 0 and 2 pi. So I'm going to write an inequality based on my standard endpoints. They're at 0 and 2 pi. And so I'm going to input my argument, 2x minus pi over 2, to this inequality. And again, the goal is to see the fact that we've multiplied by 2, we've subtracted pi over 2, how does doing that affect those standard period endpoints of 0 and 2 pi? So I want to isolate my x, and once I do that, on the left and right will be my new endpoints for the new period that I'm going to graph for the actual function that I'm graphing. So I'm going to start by adding pi over 2 to both sides. So add pi over 2 to 0, we get pi over 2. We still have our 2x. And then 2 pi is the same thing as 4 pi over 2. So if we add pi over 2 to 4 pi over 2, we'll get 5 pi over 2. Okay, now we need to divide the 2. And again, just like when we divided the 2 up here, be really careful. These 2's are not going to cancel out. Dividing by 2 is the same thing as multiplying by 1/2. So the 2's are not going to cancel, they're essentially going to combine and multiply together. So pi over 2 divided by 2 is going to be pi over 4. Okay, we've isolated our x, that was the goal. And then 5 pi over 2 divided by 2 is going to be 5 pi over 4. Okay, so these will be the new starting and ending values for the single period we graph for our cosine function. So a couple things to notice here about these values. Number one, notice where we're starting. We're starting at pi over 4. Well, we determined that the phase shift was pi over 4 units to the right, so it makes sense that we're now starting rather than at 0 at pi over 4. So that's again because of that phase shift. The other thing to notice is that if you go from pi over 4 to 5 pi over 4, there's a difference of pi units. So 5 pi over 4 minus pi over 4 would be 4 pi over 4, which is the same thing as pi. That's because our period is pi. The period is how far we have to go from where the graph is going to start to where it's going to end, and then again repeat. So both of these two values are demonstrated here when we determine where the new period is going to start and where it's going to end. Okay, so our graph will start at pi over 4, it'll end at 5 pi over 4. Now, as we graph, not only do we need to know where we start and where we end, but we need to know how we transition from one key value to the next along this period from pi over 4 to 5 pi over 4. So if we essentially think of one period's key features, we start at the center, or excuse me, we're graphing a cosine. So we start at the maximum, we go to the center of the graph, we go to the minimum, back to the center, and then back up to the maximum, and we complete a period. So essentially those 5 points divide our period into 4 equally sized intervals. So as we travel from pi over 4 to 5 pi over 4, we're traveling across 4 equally sized intervals. So we want to know, well, where do those specific key values fall based on the fact that we've divided the period into 4 parts. So what are the units going to be that we use to graph in order to accurately label what's happening as we transition across the period? So to determine that, we need to take our period, which is pi, and divide it into 4 equal parts. And in this case, we get pi over 4. What does that represent? It represents how far we have to go from one key location on our graph to the next as we transition across that period that happens to be pi units long. Okay, so everything we need to know to get an accurate graph, we now know. So all of the information here is going to be reflected horizontally on our graph. And then our amplitude and our vertical shift will be involved vertically. So let's actually start with the vertical part, because generally that's easier to label. It's a little bit less work. So we have to keep in mind that two things have changed vertically. The amplitude is higher than the original cosine function. The original cosine has an amplitude of 1. And then normally cosine is centered at 0, where now we're shifting everything on the graph up 2 units. So both of these pieces of information need to be reflected on our graph as we label. So I'm going to start with the vertical shift, and I like to start at the center of the graph. Normally the center is truly the x-axis, which is at y equals 0, but we've shifted everything up by 2 units. So y equals 0 is no longer the center. Now the center of the graph is at 2 units above, which is y equals 2. Okay, now from there, the amplitude tells us we have to go 5 units above the center, we have to go 5 units below the center to hit the relative maximum and minimum values. So starting at a new center of 2, we have to go up 5 units, which would take us up to 7, and we also have to go down 5 units, which would take us down to -3. So it's important to keep in mind once we've started labeling that even though this looks like the y-axis and the x-axis, they may not actually represent those at this point. The x-axis falls at y equals 0. Well, if this is y equals 2 and this is y equals -3, the actual x-axis is somewhere between those. So actual x-axis is somewhere in between. And you can label it if you want. You can wait till the end to label it if you want. Just keep in mind that this is not actually the x-axis anymore. Essentially, we've shifted the picture and we're using the labeling just to make the graphing a little bit more easy. But the actual x-axis is somewhere between that midline and then that location where we hit the relative minimum at -3. Okay, now let's do some of the horizontal labeling. So we know our graph is going to start at pi over 4. Horizontally speaking. So normally we start at 0, aka the y-axis. We're actually going to start at pi over 4 instead. So where our graph normally starts, I'm going to label pi over 4. Okay, now automatically that means 0 would be somewhere out here to the left. So the actual y-axis, if we wanted to label it, is going to be somewhere to the left of where we're actually starting our graph. So keep that in mind. Okay, now 5 key points, again, divides the graph into 1, 2, 3, 4 equally sized intervals. And we know that once we cross those 4 intervals, we should end at 5 pi over 4. Now what we want to know is where do those key locations in the middle fall? And they're spaced pi over 4 units apart because we've divided the period of pi units into 4 parts. So essentially we start at pi over 4 and we're going to add on another pi over 4 to transition along the period to from where the period starts to where the period ends. So pi over 4 plus pi over 4 will give us 2 pi over 4, which reduces to pi over 2. So I'm going to label it as pi over 2, but I want to keep it in my mind that that's really a 2 pi over 4. So 1 pi over 4, 2 pi over 4, add on another pi over 4, and we get 3 pi over 4, which doesn't reduce. Okay, 3 pi over 4 plus pi over 4 is going to give us 4 pi over 4, which reduces to pi. And then 4 pi over 4 plus pi over 4 is going to give us 5 pi over 4, and we end exactly where we're supposed to. So once we have everything labeled, all we need to do is fill in the standard points for the cosine graph based on where they normally fall. So remember, cosine is going to start at its maximum, it's going to go to the center, go down to the minimum, back to the center, and back up to the maximum to complete a full period. So our new relative maximum occurs up at 7, and then we transition to the center, down to the relative minimum, back to the center, and then back to our relative maximum. Okay, we connect the dots with a curve. keeping in mind that cosine and sine graphs are graphed in the shape of a wave, and that's going to be 1 period of our cosine graph. Now, if we're graphing on paper, we're done. That's all we need to do. As long as both axes are labeled and we have 1 full period graphed, we're done. But how do we translate this into the homework system? Well, what we're going to end up doing is we're going to end up plotting these specific points in the homework system. So what I want to do now is I want to label the actual coordinates for these points. I want to list out the actual points we graphed. Okay. So along this horizontal axis we have the x values, and along the vertical axis we have the y values for each of these ordered pairs. So our first point starts at pi over 4 for x, and then the y value is 7. So that point is going to be pi over 4, comma 7. So that'll be an actual point that we'll either drag and drop on the grid or we'll plot using the point plotting tool. Okay, the next point is going to be at pi over 2, and then notice it's not at 0, the y value is 2. So our next point falls at pi over 2 and 2. Okay, next point, 3 pi over 4, and we're down at negative 3. So 3 pi over 4, negative 3. Okay, next point, pi, and we're back at 2. So pi, comma, 2. And then our final point is at 5 pi over 4, and we're back up to the relative maximum at 7. So 5 pi over 4 and 7. So those 5 points will be the points that we'll plot when we want to put this in the graphing system. So let's flip back over, let's input those points, and let's see if we can get an accurate graph. Okay, give me a minute to find my screen. There we go. Okay. So our first ordered pair was pi over 4 and 7, and let's take a look at the grid we have here. So the x-axis is labeled using units of pi over 4, so that's good. Notice everything we graphed was a multiple of pi over 4, so a lot of the work has already been done for us here. So we won't necessarily have to use the point plotter just for the sake of getting pi over 4, pi over 2, 3 pi over 4, that kind of thing. It's already labeled with those values. And then we go up to a maximum of 7, down to a minimum of negative 3, and those values are already labeled for us. So great news here. We've got everything we need just to drag and drop points directly onto the grid. That means we can use the pencil rather than having to use the plot a point tool. So I'm going to use the pencil, and I'm just going to scroll around and plot the points I need. So my first point is at pi over 4, and then the y coordinate is 7. So I'm going to drag and drop it. Okay, there's my point. Next point is at pi over 2 and 2. So think of that as the midline of the graph. We have 3 pi over 4, negative 3. So I'm going to plot that. Then we have pi and 2. And then 5 pi over 4 and 7. Okay, and that's everything we need. Now that we've got those 5 points, we've got that full period, we can use the graph a function tool. It's going to connect it, and notice it's going to graph the whole thing. So we graphed 1 period by hand, it's going to graph the whole function with the understanding that we continue to the left and continue to the right in the same manner. So let's check the answer, make sure it's correct. Okay, looks good. So that's what you need to do in order to graph a sine or a cosine function. Now, what happens if you press that graph a function button and things just aren't working out, you're not getting the correct shape? What does that mean? How do you fix it? Normally, it means one of two things. Number one, it could mean that maybe you didn't actually graph a full period. Maybe you only graphed 4 points instead of graphing 5 points. Keep in mind, if we're starting at the maximum, we have to transition all the way back to the maximum. So we've only completed a full period once we do that. So if you're missing some points, that would be one example of why the system would not graph your function correctly. So that's one possibility. The other more likely possibility is one or more of your points is incorrect. And again, that's one of the main reasons why we like to work out as much as we can on paper. Do the graph on paper first, because it's going to be easier to find a mistake. If you made a mistake maybe counting horizontally, maybe your starting and ending points were incorrect, something like that, so the points in the middle were affected as well. Ultimately, go back and check your handwork, and you may be able to notice a mistake there based on how you labeled the graph and how you were able to plot those points. Another possibility is maybe if this was a cosine, you actually graph the points for a sine function. Keep in mind that that can happen as well. Make sure you know that cosine starts at its maximum, sine starts at the center line. So that definitely results in a different graph. But all in all, this is generally how you graph a function using sine or cosine in the Connect Math and ALEKS systems.